All right, let us begin. We're going to talk about simplifying radicals today, and as you can see from this first problem, we have square root of 25 times 4, both under the radical, right? The way we do that, there are actually two ways to do that. The first way is you multiply the numbers in the radical, under the radical, so you get 25 times 4 equals 100. So this is the square root of 100 equals 10. The alternative way, by the way, you will be using both ways, depending on which way is easier. So the other way is to separate these using our product property for radicals. So you can say if these are the same roots, you can separate them as the square root of 25 times the square root of 4 and simplify them individually. So you get 5 times 2 equals 10. All right, and for the same goes for the quotient property, the fractions that we dealt with last Friday, right? So if we have the square root of 100 over 4, you can separate these as the square root of 100 over the square root of 4, which then simplifies to 10 over 2. And whenever you have a fraction that can be reduced, please do so, right? Moving on, we have a bunch of examples here. Let's simplify these. So square root of 18. Let me use a thicker ink here. So square root of 18, as you can see, we decided to separate these to 9 times 2. The reason we chose 9 times 2 is this. Look at our perfect squares. Let me write these out pretty quickly here. 3 squared is 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100. I told you to, I asked you to memorize up to the 15 squares if possible, because that's where we are, those are the perfect squares that we use most frequently. So I look for the perfect square that's the largest, that divides into 18, and I see that it's 9. That's why we choose 9. So then we have square root of 9 times the square root of 2, which is 3 root 2. So if you move on to 75, right? Root 75. What's the largest perfect square? So it can't be 64, 49, right? We keep going down to 25. So 25 and 3 gives me root 25 times root 3. That simplifies to 5 radical 3. Okay, so that's why it's a good idea to really have these numbers memorized. Next part, C. Square root of 27x cubed. I see that 9 is the largest perfect square. So I do 9 times 3, right? As you can see here, that's the 9 and the 3. Now look at the x cubed. We have a variable. So since this is a square root, right? The perfect squares have to be multiples of 2. So what's the largest multiple of 2 in the 3? It's 2, right? So I have 2 and then I have 1 left over. So I write it as the square root of 9x squared and the square root of 3x to the first. That can't. So now we can simplify that to 3x, right? 3x times root 3x. Okay, let's try the next one. The next one we have square root of 72a cubed b to the fourth. And I see that the largest perfect square in 76 is 36, right? 36 times 2, right? 36 times 2. So I look at my variables. Since this is a square root, right? I need this to be a squared b to the fourth. That leaves me a to the first left over here on the right side, right? So let's simplify this. We get square root of 36 is 6. A square root of a squared is a. Square root of b to the fourth is b squared. And we have times radical 2a as our final answer. Let's look at some examples now. Square root of 45. So in this first problem, I see that 9 is the largest square root. So what I'll do is I'll write square root of 9 times the square root of 5. which simplifies to 3 root 5. Pretty easy, right? Square root of 200, I see, can be simplified as the square root of 100 times the square root of 2, which is then 10 root 2. For part C, I see that the 75 is 25 times 3, right? So I'll do the square root of 25, and the p has to be to the 4th power, multiple of 2, right? Square root. So we have 3 times p left over. So now the first radical simplifies to 5p squared, radical 3p. Alright, and the last one, I see that 98 is actually 49 times 2. So this is the square root of 49. I see that m should be m squared n to the 4th. Right? What's left? We have 2m. So if I simplify the first radical, I get 7m n squared times radical 2m as my final answer. Okay, moving on. Over here, we're looking at some cubed roots now, and I can see that. Okay, for the cube roots, we should definitely know up to 5 cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed 125. These are the most commonly used for our class. So let's look at what number cubed. What's the largest number cubed that you see for the factor of 48? Can't be 64, can't be 27, right? It's actually 8. So we split this up into 8 times 6. So cube root of 8, this is my 2, right? Perfect cube, right? And then you get 2 cube root of 6. Let's look at the next one. Cube root of 24, what's the largest? I see is 8 again, right? So we've got 8 times 3. So now, because this is a cubed root, I need my variables to have the exponent that's a multiple of 3, right? For cube root. For the square root, it was multiples of 2. Cubed root, multiples of 3. Fourth root, multiples of 4, right? You get the drift. So cube root of 8, x cubed, and we have x to the first left over there, right? Because there were a total of 4. So now this simplifies to 2x, right? That's my 2x, and then cube root of 3x. Looking at the next one, what's my largest cube? It's actually what? We have 27 times 2, right? So this is the cube root of 27, and then the cube root, so this has to be a multiple of 3, so it's 6, and then we have b to the third, right? And what's left over? The 2, a to the first, b to the first. So we split these up, and this simplifies into 3a squared b, right? Cubed root of 27 is 3. Cube root of a to the 6 is a squared. Cubed root of b cubed is b, right? And then the remaining factor. Any questions up to this point? Let's do these examples. Okay, cube root of 128. So what's the largest cube there? I see 64. So this is the cube root of 64. W has to be a multiple of 3, right? And then cube root of the remaining factors, 2w. So now this is equal to 4w cubed root of 2w, right? Next one, what's the largest cube? It's actually 8, right? 8 times 5 gives me 40. So this is cube root of 8x. So x to the third, y to the 6, right? Multiples of 3. Cubed root of, what's left? 5. There's an x squared left and a y to the first left. So now this simplifies to 2xy squared cube root of 5x squared y as our final answer. The last one, what do we see here? So 64 doesn't work, 27 doesn't work, 8, right? 8 doesn't work. So, oh, I'm sorry, this is the fourth root we're looking at. So let's write out the fourth roots real quick. We got 1 to the fourth is 1, 2 to the fourth. Oh, by the way, easy way to do these is to square it twice. So I do 2 squared is 4, and then 4 squared is 16. 3 to the fourth, we could just do up to here, right? 3 to the fourth is, 3 to the fourth is 3 squared is 9, 9 squared is 81. So I see 16 is the largest, right? To the fourth power. So I got fourth root of 16, because it's 16 times 3, and then multiples of 4. So this is a to the eighth, b to the fourth, times the fourth root of 3b. So what is this? This is actually 2a squared b times the fourth root of 3b. All right, any questions? Okay, let's take a look at this one. So we have the square root of 5 over 9. So earlier we talked about the rule, the property where you could split these up, right? So let's split these up and we get square root of 5 over the square root of 9. Now, the square root of 9 simplifies, right, into 3. But the root 5 does not. That's why our final answer is just root 5 over 3. Any questions? The next one, we do the same, right? We use the same property. We split them up into 2 fractions. So we get the square root of a to the fourth over the square root of 25. Now, the square root of a to the fourth simplifies to a squared. Square root of 25 simplifies to 5. So the final answer is a squared over 5. Now, in part C, it gets a little more complicated. So we split these up, we get cubed root of 5x squared over cubed root of 8. So you just make sure you know your cubes, right? 5 cannot be simplified, right? There's no number cubed that gives you 5, right? Same for the x squared. But the 8 does, right? It's actually 2, so you get cubed root of 5x squared over 2. So let's try these examples on the bottom. We get, for the first one, square root of 7 over the square root of 16. 7 does not simplify. The square root of 16 becomes 4. Next one is radical 3 over radical 25a squared. So we get radical 3 over 5a. And the last one is the cubed root of 5x over the cube root of 27. So again, we get cube root of 5x over 3. Any questions? Okay. We're going to talk about rationalizing the denominator, which you can see right here, rationalizing the denominator. Now in these problems, you'll see that when you split them up to, like, root 3 over 5 becomes root 3 over root 5, we're not supposed to have radical in the denominator, so we have to multiply it by some number to get rid of the radical. So in terms of square roots, generally we multiply it by itself, right? But we want to multiply it by whatever number that gives us the smallest perfect square. That's probably the best thing to do. So for root 5, it's actually, root 25 is the smallest perfect square. We get that by multiplying by radical 5. So you multiply both the numerator and the denominator so that we don't change the value of this number, right? What is root 5 over root 5? It's actually just equal to 1, right? So we're not actually changing the value. So we just make it look different, right? So we do root 3 times root 5 is root 15, and root 5 times root 5 is root 25, which is equal to 5, right? So let's try that for this next one. So this becomes root 3 over root 7, and root 49 is the smallest perfect square. So we have to multiply this by root 7 over root 7. You see how that's equal to 1, so we're not changing the value. So this is radical 21 over radical 49, which is equal to 7, right? So radical 21 over 7. Okay. You will see in these problems, let's do them. Okay, so we have 3 over root 8, right? So this is why you don't want to multiply it by itself. Just don't assume that this radical 8 is what you're going to multiply by, because look at what happens here. If I do this, radical 8 is some number I have to simplify, right? So this becomes 3 root 8 over 8, but radical 8 needs to be simplified. So this is root 4 times root 2, right? So this is actually 3 times 2 root 2 over 8. You see how tedious that is, right? Extra work, and then the 2 cancels out, so you actually get 3 root 2 over 4, right? So this is tedious. So what you want to do is find the smallest radical that'll give you a smallest perfect square, right? Well, not the smallest radical, the radical that'll give you the smallest perfect square. So 16 is my smallest perfect square. So what I'll do is I'll multiply by root 2 on both the numerator and the denominator. That way I get root 8 times root 2 is root 16, which is equal to 4. So you see how much easier this method is when you multiply, when you try to look for the smallest perfect square first and then multiply by that number, whatever that number that is. So look at part B. This is, you split it up to, you get cube root of 5 over 4 is equal to cube root of 5 over the cube root of 4. And we're looking for the smallest cube, right? Which is actually what? 8, right? Because you get 1 cubed is 8. I'm sorry, 1 cubed is 1, 2 cubed is 8, right? 3 cubed, 27. So 8 is the smallest. So I can multiply this by the cube root of 2 over the cube root of 2. That way, this becomes, the denominator becomes the cube root of 8, which simplifies to 2. The numerator, you can just multiply, right? 5 times 2, and you get cube root of 10, which you cannot simplify. So basically, that's what we're doing here, okay? Let's try it for these examples. So 5 over root 12. So the smallest perfect square, right? What would that be? So we know that like 1 squared, 2 squared is 4, 3 squared. So it's not these small ones, right? So I'm starting to look at 6 squared, right, is 36, right? 6 squared equals 36. So if I actually multiply this by the square root of 3 over the square root of 3, you see how the denominator is now equal to root 36. Numerator is 5 root 3, right? So now you get a nice fraction, 5 root 3 over 6. For the next one, you separate these, right? So let's do that down here. The smallest cube is 27. So I'm going to multiply this by the cube root of 3. Right? That way I get cube root of 27 in the denominator. Numerator is cube root of 2 times 3 is 6. You can't simplify the numerator, but the denominator becomes 3. Right? Pretty easy, I hope. let's look at some variables now. So over here we got the square root of 8x cubed over 3y. So first we use the quotient property to split them up, right, into two fractions. Now, you see how the denominator's radical 3y? So that one we can multiply by root 3y. Root 3y. When you do that, you see the denominator is now radical 9y squared, right? Because you need the exponents here to be multiples of 2, square root, so 2. The numerator, you end up with 24x cubed y. Now this is the part you have to really be careful so you don't make little mistakes here. So the 24, the largest square root here is actually what? It's 4, right? So this is the square root of 4x squared times what? 6. 4 times 6 is 24, right? And you get 6xy over square root of 9y squared. We could simplify that right now if you want. You don't have to, right? So what do we have? This is equal to 2x square root of 6xy over 3y. Okay? Let's look at the next example. We have 2 over the cube root of 3x. Now, this is the cube root, so this is where you have to look at numbers cubed, right? So the smallest that I see is 27x cubed. So what do I multiply this to get 27x cubed? 27x cubed, right? So that's what? 9x squared. Do you see it? So cubed root of 9x squared, cubed root of 9x squared. So the numerator is 2 cubed root of 9x squared, and the denominator is cubed root of 27x cubed, which then simplifies to this. And whenever I have numbers outside of the radical, I just want to double check to see if anything cancels out. In this one, it doesn't. So we're done. So let's try some examples here. I'm going to zoom in a bit to get more space. Let's do the first one. So this we separate first, right? We get the square root of 12a cubed over square root of 5b. So to rationalize the denominator, it's 25b squared, so I get root 5b, root 5b, right? The numerator, you can combine them first, or and then work the other way, but I like to just kind of do the separating, because I see 5 is a prime number, right? Nothing divides into that. The 12 becomes what? 4 times 3, right? So I can think of the 12 as root 4 times root 3, which is 2 root 3, right? So that's what I'm going to do. I'm going to separate this as root 4 and then look for the variables. A squared, that's my perfect square, times what's remaining? The 3 and the 5. So the 3 and the 5, a and the b. And the denominator is 25b squared under the radical. All right, does that make sense? So now I have this 4a squared. Radical 4a squared becomes 2a square root of 15ab over 5b. Then I double check outside the radical, anything canceling out? No, they do not. Okay, let's see the next problem. We have cube root, right? So the smallest cube that I see is an 8w cubed. So I got to multiply this by what? The cube root of 4w will give me 8w cubed. Oh, sorry, 4w, right? And the numerator is 3 cubed root of 4w. Denominator is cubed root of 8w cubed, which then simplifies to 3 cubed root of 4w over 2w. And then I check outside to see if anything cancels. It does not, so we are good to go. Alright, I think the ones that gave us the most trouble were down here. So let's just practice these 6 and then we'll be done. Alright, we have first one, we have to multiply by radical 7 over radical 7 to get 5 radical 7 over radical 49, which is 5 radical 7 over 7. Now, quick note, we talked about this earlier, right? When we do a radical 7 times radical 7, we can just skip this step here and just write 7, right? So just wanted to make a note of that so we could start doing that. So this next problem, we separate to radical 5 over radical 8, and we want to multiply this, oh, that should be an equal sign. We want to multiply this by root 2 over root 2, right? That'll give us radical 10 over radical 16, which is then radical 10 over 4, right? Next one. So it's radical 12. We want the smallest radical, which is radical 36, right? So I can multiply this by radical 3 over radical 3 to get 7 radical 3 over radical 36, and that gives us 7 root 3 over 6. The fraction outside does not simplify, so we're done. Next, we have root 5 over root 11. This one is just radical 11 over radical 11. So radical 55 over 11. Remember, like number 51, radical 11 times itself is just 11. Okay, 55. So this one is just radical 10. So we get 2 radical 30 over 10, right? But quickly, you want to make sure you simplify this, right? This rat simplifies to 5, so radical 30 also does not simplify, right? So you get radical 30 over 5. And the last one, multiply by radical 3 over radical 3. We get 3 radical 15 over 3, right? And we see the 3's cancel out. Radical 15 is our final answer. Any questions?